always talking about balance, right? Like finding that sweet spot
Yeah.
with work and life and, finding the right seasoning in our food. But what about our bodies? Did you know that our bodies are constantly working overtime
Yeah.
to keep everything in a really delicate balance?
It is.
So today we are diving into the fascinating world of pH.
Okay.
We are going to be looking at how our bodies walk this really, really tightrope between acidity
Yeah.
and alkalinity.
And it's a delicate balance.
Oh, yeah.
It's way more delicate than I think people think.
Really?
Like, have you ever thought about, like, what would happen if your blood pH
Oh, gosh. No.
got too far out of whack?
I don't even want to think about it.
You would, it would be incompatible with life.
Oh, my gosh. Okay, so we're not just talking about, like,
No.
little heartburn here.
No.
This is serious stuff.
This is serious stuff.
I remember pH from chemistry class.
Okay.
But what's the big deal when it comes to, like, our bodies?
Well, so you can think about your body as this, like, complex chemical symphony.
Okay.
Where you've got all these different organ systems playing their part.
Okay.
And you've got acids and bases that are constantly, like, interacting and releasing and accepting these things called hydrogen ions.
Hydrogen ions?
Yeah, you remember those, right?
Hopefully.
From chemistry.
Come back slowly.
They're these, like, tiny little charged particles that basically determine whether something is acidic or alkaline.
Okay, so the more hydrogen ions there are, the more acidic something is.
Precisely. That's exactly it. And that's what the pH scale actually measures.
Okay.
It's like how acidic or alkaline something is.
Got it.
But here's where it gets really, really cool.
Okay.
Our bodies, they can self-correct.
What?
Yeah, like even when we're throwing acidic foods and drinks into the mix.
Oh, wow.
Our bodies are like, whoa, hold on, let me adjust.
That's incredible.
I know. And Dr. Clarkson in this lecture really emphasized this idea of compensation.
Compensation.
Yeah.
So it's like our own internal balancing act.
Exactly.
To kind of keep things in check.
Yeah, it's amazing.
But he also mentioned that this balancing act, like, it has its limits.
Right.
Like, what happens when we push things too far?
That's when we start getting into trouble with acidosis.
Acidosis.
Yeah, which means you're becoming too acidic. Or alkalosis, which means you're becoming too alkaline or too basic.
Okay.
And these aren't just like abstract concepts.
Right.
They have a real impact on how our bodies actually function.
So this is like real life stuff happening.
Absolutely real life stuff.
In our bodies all the time.
All the time.
Like what? Give me an example.
Okay, so think about when you're working out.
Okay.
Right? And you're like really pushing yourself hard.
Yeah.
And you feel that burn in your muscles.
Yes.
That's lactic acid building up. That's a classic example of acidosis.
Really? I always thought that burn was just my muscles being like,
right,
take it easy.
Yeah.
I had no idea that it was related to my pH levels.
It's all connected.
Wow. Okay, so that's fascinating.
Yeah.
But what happens when it's not just like a quick burst of exercise? Like what happens when things go too far in either direction? Like what are the real world implications of this?
Well, to really understand that, we need to bring in the key players who are responsible for this balancing act. And those are the respiratory and metabolic systems.
Okay.
It's like this carefully choreographed dance between your lungs, your kidneys, and a whole bunch of other chemical messengers.
A dance to maintain pH balance.
That's it.
Okay, I'm intrigued now.
Good.
So who are our dancers?
All right, so let's meet them.
So picture this. The respiratory and metabolic systems are two-star dancers, working tirelessly to keep our blood pH perfectly balanced.
It's a beautiful analogy.
Yeah.
Your respiratory system, with its lead dancer, the lungs, focuses primarily on expelling carbon dioxide or CO2. You see, CO2, when dissolved in your blood, is actually quite acidic.
Oh, really?
So every time you breathe out, you're essentially removing a source of those acidity-increasing hydrogen ions.
So breathing isn't just about getting that sweet oxygen, it's also our body's natural way of regulating acidity. That's amazing. But where does the metabolic system come into play in this intricate dance?
That's where the kidneys take center stage.
Okay.
They're responsible for regulating bicarbonate ions, HCO3. Think of them as the opposite of those acidic hydrogen ions. They're alkaline and help neutralize acidity.
So our kidneys are like the body's bicarbonate factories, pumping out more when we're too acidic and cutting back when we're too alkaline.
Exactly. They're constantly fine-tuning the balance to keep everything in harmony.
So we've got the lungs expelling CO2 to reduce acidity, and the kidneys adjusting bicarbonate levels to do the same. It's fascinating how these two seemingly separate systems are working together in perfect sync. Dr. Clarkson's lecture mentions something called the anion gap. What is that exactly, and how does it relate to all of this?
Ah, the anion gap. Think of it this way. You know how doctors run blood tests to check for various things? Well, the anion gap is one of the tools they use to understand what might be causing a pH imbalance. It's a calculation based on the levels of different charged particles in your blood, and it can help pinpoint the root cause of acidosis, for example.
So it's like a detective's clue, helping them determine if the imbalance is due to a problem with the respiratory system, the kidneys, or something else entirely.
Exactly. It's a powerful tool for diagnosis. Now, let's go back to those real-world scenarios we were discussing. Respiratory alkalosis, for example, can be caused by something as common as hyperventilation.
Hyperventilation, like when you're having a panic attack and can't seem to catch your breath.
Exactly. During those moments of intense anxiety, you're actually expelling CO2 at a faster rate than your body can produce it.
Wow.
This rapid decrease in CO2 leads to a more alkaline state in your blood respiratory alkalosis.
Wow. So even our emotional state can have a direct impact on our pH levels. That's incredible. But Dr. Clarkson's lecture also mentioned other causes of respiratory alkalosis beyond panic attacks, right?
Absolutely. Think about someone climbing a mountain at high altitude where the air is thinner. The lack of oxygen can trigger faster breathing, leading to, you guessed it, respiratory alkalosis. Even certain medications or underlying medical conditions can disrupt the CO2 balance in our bodies.
It's fascinating how something as simple as breathing can have such profound effects on our internal balance. But we've focused a lot on alkalosis. Let's switch gears and dive into a more serious consequence of acidosis. Diabetic ketoacidosis, or DKA, as Dr. Clarkson referred to it.
DKA is a prime example of how metabolic acidosis can turn life-threatening.
Really?
In individuals with diabetes, especially type 1, their bodies struggle to use glucose or sugar for energy due to a lack of insulin. As a result, their bodies start breaking down fat for fuel instead.
And that's where the trouble begins.
Yes, exactly. Breaking down fat for energy produces ketones byproducts that are highly acidic. These ketones build up in the bloodstream, throwing the pH balance off and leading to metabolic acidosis.
So unlike respiratory acidosis, which is primarily driven by breathing and CO2 levels, metabolic acidosis stems from problems within the body's metabolic processes, like in DKA, where the body isn't processing glucose properly.
Precisely. It's a crucial distinction. And remember that anion gap we talked about earlier. It's particularly helpful in diagnosing metabolic acidosis and figuring out what's causing it.
So DKA is a serious condition that highlights how vital this intricate dance between our respiratory and metabolic systems is for maintaining the delicate balance within our bodies. Are there any other examples from Dr. Clarkson's lecture that you think would be particularly illuminating for our listeners?
Absolutely. Let's delve into the world of health.
This is wild. Like, our bodies are constantly making these tiny adjustments to keep everything balanced, but like you've been saying, sometimes our bodies get thrown off, and that's when things can get kind of scary.
It is kind of like our bodies are these finely tuned instruments.
Oh, I like that.
And if we pay attention, we can hear when things are a little out of tune.
So, like, what should we be listening for? What are the signs that our pH is a little off?
Well, Dr. Clarkson mentioned muscle weakness.
Really?
Yeah.
I wouldn't have thought of that as a
Yeah.
pH thing either.
Me neither. It's actually pretty common, though, especially when your blood is too acidic.
And that's because of those hydrogen ions, right?
Exactly. Too many of those. And it's like everything gets a little gummed up, including the processes that allow our muscles to work properly.
So it's like our body's way of telling us to ease up and get things back in balance.
Exactly.
What about when our blood is too alkaline? What kind of signs should we be looking out for?
Well, there's a condition called tetany.
Tetany.
It's often linked to alkalosis,
Okay.
and it's all about calcium.
Ah, right. Calcium. What does calcium have to do with it?
Well, calcium is super important for a lot of things, like how our nerves send signals and how our muscles contract.
Right, of course.
And when your blood is too alkaline, it can mess with how your body uses calcium.
So what happens when someone has tetany?
Imagine this. You start feeling this weird tingling, like pins and needles, around your mouth and in your fingertips.
Okay, that sounds kind of uncomfortable.
And then your muscles, especially in your hands and feet, start to spasm.
Oh, wow. And all that from a little pH imbalance. Our bodies are crazy.
It really goes to show just how interconnected everything is. Our bodies are constantly working to keep all these different systems in balance.
Right. It's like Dr. Clarkson said at the end of his lecture. He quoted something from the Bible about salt.
Matthew 5.13. You are the salt of the earth. But if the salt loses its saltiness, how can it be made salty again? It is no longer good for anything except to be thrown out and trampled underfoot.
It's an interesting comparison because what does salt have to do with pH?
Well, think about it this way. Salt is more than just something that makes food taste good.
Right, it's a preservative.
Exactly.
Mm-hmm.
It used to be super valuable, and in a lot of cultures, it represents things like wisdom and purity.
Oh, okay. I see where you're going with this.
It's about balance. Just like our bodies need that balance of acidity and alkalinity, we need balance in our lives too.
Wow, yeah. Okay, that's a really cool way to think about it.
If we lose that balance, if we lose our saltiness,
Mm.
we're not really fulfilling our purpose.
It's like we're not showing up as our best selves, right?
Exactly.
This has been such a fascinating deep dive. We've learned so much about how our bodies work and how important it is to maintain balance, not just physically, but mentally and even spiritually. It makes you realize that everything is connected.
It really is amazing.
So as we wrap up, we want to leave you with this. How can you keep your saltiness? How can you cultivate more balance in your own life? Think about that, and until next time, keep exploring, keep asking questions, and keep searching for that balance.